Hello friends, so here is another question on equation of motion. So it is given that a boy stretches a stone against the elastic rubber band of a catapult toy. A small kind of a triangular shape, V-shaped metallic or wooden, kind of an arrangement attached with a rubber band which is used to hit small stones at targets. Kids play with that, so that kind of a toy. So catapult toy through a distance of 24 centimeter before releasing it. So that tape or rubber band, it returns to its original position, providing an acceleration to the stone, okay, over the stretched length. The stone then leaves the catapult with a speed of 2.2 meter per second. Assuming the acceleration to be constant while the stone was being released from the band, we have to find its magnitude. So such a lengthy question, but let us try to understand what we have to do. So first, here it is given that we have a toy, kind of a like this catapult toy. It has a rubber band attached to it, okay, like this, and it is used to stretch a stone. So this is the toy, this is the arrangement. Now it is given that this toy, it is stretched, the rubber band is stretched through a distance of 24 centimeter from its original position. 24 centimeter. Then it is released. So what happens? The rubber band returns to its original position, and it is given that this stone, it leaves this position with a velocity or speed of, at this point, 2.2 meters per second at this position here. So we have to find the acceleration, okay. So now here, when the rubber band was stretched up to 24 centimeter behind this position, this initial position here, this point, initially its velocity was 0. The velocity of the stone was 0. It was stretched through a distance of 24 centimeter or 0.24 meter, that is the S, the distance or displacement, because it is happening in a straight line. Then finally, when the rubber band is released, the stone, when it reaches this point, its velocity is 2.2 meter per second. So this is here the final velocity of the stone, okay. So we have V, we have U, final velocity, initial velocity, and we have the stretched length, which is the distance, okay, or the displacement, whatever you can call it, because it is happening in straight line. We have been asked to find the acceleration. So we have to use such an equation of motion which involves V, U, S and A. So the obvious choice is V square minus U square is equal to 2AS. This is the perfect choice for it. Okay, so we'll just simply put the values. Final velocity 2.2 whole square, initial velocity 0 square, which is equal to 2a into 0.2 That implies A is equal to 2.2 whole square minus 0 whole square by 2 into 0.24, which is equal to, if we calculate, it will come around, okay, let us 2.2 square by 2, it is coming around 10.1 meters per second square. This is the acceleration. This is what we were asked to calculate, the acceleration. So here the solution is very simple. The solution is very small and simple, but the important thing is to understand the question. When you first look at the question, it looks like a very lengthy, complicated one, but if you read it properly, carefully, then you realize that it's actually a very deliberately I have chosen this question. When you first look at the question, it looks like a very lengthy, complicated thing, but when you properly read the question and try to understand it and try to convert it into a suitable diagram so that you can understand what is being asked and how I can use equation of motion and which equation of motion I can use to solve it. So assigning the correct values and the correct parameters, choosing the right parameters, that is very important. Here figuring out that here s is equal to this much, initial velocity is equal to this much, figuring it out, final velocity is this much, that is very important. Assigning proper values to parameters. Okay, understanding the question, first reading the question, understanding it, converting it to a suitable diagram, assigning the correct values to the correct parameters, and then figuring out how to solve it. That is the only thing. So deliberately I have chosen this very, when you look at the question, it looks lengthy, complicated, but it's actually very simple. Okay, so this is the solution. So here is another question. It is given that a body is dropped from rest from a height of 150 meters and simultaneously another body is dropped from rest from a point 100 meters above the ground. Okay, what is the difference in their heights after they have fallen for a duration of 3 seconds? Here we have to take acceleration due to gravity, small g equals to 10 meter per second square. Okay, so this is the question. Now let us try to convert it into a proper diagram. So let us say we have a tower or something like that, or a tall building. Okay, like this. So here first a stone is dropped, or a body, let's say a stone is dropped from a height of 150 meter. Okay, here 150 meters from the top. Here a stone is dropped from rest, u equals to 0 meters per second from rest, it is dropped, and then simultaneously at the same time, exactly at the same time, another stone is also dropped from rest. Both of the stones are dropped from rest with 0 initial velocities. Now we have to determine, let's say after 3 seconds, okay, after 3 seconds, what is the difference in their heights? Let's say both the stones are here and there after 3 seconds. Okay, both the stones. We have to determine what is the gap between them, the height difference between them. Okay, so for that we have to take each stone separately. Let us say this stone, okay, let's call it number 1. Okay, let's call it number 1 and let's call it number 2. Stone number 1. Okay, initial velocity is 0. It is directed downwards. The stone is moving downwards. Acceleration due to gravity is also downwards. So here G will be taken as positive. Okay, so here the distance traveled by the stone in 3 seconds for stone number 1 is equal to ut plus half gt square. U is 0, so this will be 0, simply half into 10 into t square, that is 3 square. So this is 5 into 9, that is 45 meters. So stone number 1 has traveled 45 meters. It was dropped from a height of, initial height of 150 meters from the ground. So now after traveling a distance of 45 meters downward, the height from the ground, the height of stone 1 from the ground is equal to 150 meters minus 45 meters, which is equal to 105 meters. Okay, this is the height of stone 1 from the ground after traveling 3 seconds. Similarly, stone number 2, same thing. Initial velocity is 0. It is moving downwards. Acceleration due to gravity is also downwards. So both the motion of the object and acceleration due to gravity, they are in the same direction. Again, it will be taken as positive. Distance traveled by the second stone in 3 seconds, same, ut plus half gt square. U is 0, so this will be 0, it will be half into g, here we have to take g10, 3 square, same thing, 45 meters. Okay, this stone number 2, it was dropped from a height of 100 meters from ground. So now the height of stone number 2 from ground is equal to 100 meters minus 45 meters, which is equal to 55 meters. So here stone number 2 is at a height of 55 meters above the ground after 3 seconds. So it's like this. Stone number 2 is at a height of 55 meters above the ground. Stone number 2. Stone number 1 is at a height of how much? 105 meters. 105 meters above the ground after 3 seconds. This is after 3 seconds. So how much is the height difference between them? Okay, the height difference between stone number 1 and stone number 2, that is basically 105 minus 55 meters. Okay, that is equal to how much? It will be 105 minus 55, this is equal to 50 meters. So the height difference between them is equal to 50 meters after 3 seconds. Always take, be careful of that. After 3 seconds, the height difference is 50 meters. Okay, so very Good question. Application of equation of motion of an object under the influence of gravity with zero initial velocity. Always be careful assigning the value, the sign to the acceleration. When both the motion and acceleration in the same direction, acceleration supports the motion, increases, goes on accelerating, that's why positive. If they're in the opposite direction, acceleration opposes the motion, that's why it's negative. So always be careful about that. Okay, so this is the